In this video, I'll solve 5 important questions from Paper 2 2023. Let's go. In this question, we have a car that's moving. The driving force is 700 newtons. So this is the driving force. We have a drag force of 400 newtons. It's another name for friction. So driving is 700, friction is, or the drag is 400. The mass of the car is 1200 kilograms. And we have to find out the acceleration. So whenever forces and mass is given, we can use F equals ma. So we can use F equals ma. We have to be careful. This F here in this equation is the total force. Total force in our case would be 700 minus 400 equals 1200 times A. So that gives us 300 equals 1200 A. That means we solve this. A turns out to be 300 over 1200, which is 0.25 meters per second square. Okay, so that's the acceleration. But if you see, option A and B both say that the acceleration is 0.25. So which one of these is correct? Well, acceleration is positive. That means this car is going to speed up. As its speed increases, what's going to happen? The drag force is going to increase. The drag force increases, that reduces the acceleration. So option A is correct. Acceleration is 0.25, but is going to decrease as time passes. All right, so that's our first one. Let's move on to the second. This one is about circuits. It's going to be fun. So let's have a look. In this diagram, what we have is we got two resistors and the voltmeter reads 6 volts. We can use Ohm's law on the resistance. We can use Ohm's law on this resistance. V is 6 volts, so we can quickly find current. IR is 10, that means current is just 0.6 amps. Now this is a series circuit, so whatever current flows through the 10 has to go through the 30 ohm as well. So the current through the 30 ohm resistor is 0.6 amps. We can again use Ohm's law. This time we're going to use Ohm's law on this resistor here. So V equals I is 0.6, R is 30, so V is 18 volts. That was quick and we are done with this. Let's move on to the other one. In this question, what we have is a ray of light goes on, strikes the medium. If the angle is 36, it's going to go out flat. It's going to go out parallel to the interface. We increase the angle beyond 36, the ray of light is going to escape. Okay, if that's the case, let's first of all figure out how much is this angle. Well, we know 36 plus whatever this angle x is, it has to be 90 degrees. So we have 36 plus x should be 90. If we solve this, we get x equals 90 minus 36. That means x is 54. But what's so special about this angle here? The thing that's special is if you send a beam of light at 54 degrees, it's going to go out flat. If you increase the angle beyond 54, it's going to reflect back into the surface. So this angle here is nothing but the critical angle. So that's what's interesting about this question. Okay, so how do we solve this? Let's get rid of this. We know Snell's law. What does Snell's law say? It says the refractive index of the first medium, sine of the incident angle, is equal to the refractive index of the other medium in which the light is going to travel to, sine of the refracted angle. N1 is the refractive index of plastic, so let's call it N1. And sine of incident angle, if we look at the diagram, this is the incident angle. The incident angle is always made between the light and the normal. So instead of I, we are going to write 54. Equals N2 is the refractive index of air, which is 1. Sine R is the refracted angle, which is 90. So we can write sine 90. The right hand side is nothing but 1. So that's a simplification. So we get N1 sine 54 equals 1. So we can rearrange this real quick. And the refractive index is 1 over sine 54. So we can quickly plug this in a calculator and get the answer, which turns out to be, let me check my calculator. The calculator says it's equal to 1.2. So C is the correct option. Okay, let's carry on and move to the other question. All right, let's try this question. In this question, we have a seesaw which is balanced. On one side, we have a man sitting on the left side and we have two children on the right hand side. Let's have a look how many forces are present on this system. This man is 1000 Newton, has a weight of 1000 Newton. So he's applying a force of 1000 Newton. And these two children, they have the same weight, so they are applying forces of W each. Let's suppose the man is at a distance of x1, the first child is at a distance of x2, and the child further away is at a distance of x3. It's said that the plank is balanced. If it's balanced, the moments of forces should be balanced as well. That means the moment of force applied by the man, which is trying to rotate this plank counterclockwise, should balance the moment of forces applied by the children, which are trying to rotate the plank clockwise. So the moment of force applied by the man would be 1000 times x1, which is equal to the moment of forces applied by the children each. Each child closer to the pivot applies a moment of force equal to wx2. The one which is further away applies a moment of wx3. We cannot solve this equation for w. It has too many variables. So what we do is we look further and we focus on this portion of the question. So let's make a quick sketch what the question is trying to say. What happens is that the seesaw, it begins to rotate. The father, the man, he descends by an amount of 40 centimeters. So if this is the pivot, father descends by an amount of 40 centimeters and the children, they ascend. So this is 40. The first child goes up by an amount of 20 centimeters. The one which is further away rises by 80 centimeters. So if you look closely, these triangles, triangle 1, triangle 2, triangle 3 is the larger triangle. Let me highlight that. These are all right angle triangles which have the same angles. Okay, so these are similar triangles. You know, for trigonometry, if two triangles are similar, the ratio of their sides have to be the same. This distance was x1, as we said earlier. This was x2 and this was x3. So let's use some trigonometry. So what we have is x1 over 40. That's the ratio of sides in the first triangle. It should equal the ratio of sides in the second triangle. The sides in the second triangle are x2 over 20. Now let's take first triangle and the larger triangle. In the first triangle, the ratio of sides will again be x1 over 40. It should be equal to x3 over 80. Okay, so what I'll do is I'll focus on this equation first and I'll solve for x2. So if I do some algebra, I'll end up with x2 equals x1 over 2. If I do the same on this equation, I get x3 equals twice x1. I've got two equations here. So let's box them. Now what we can do is we can use these equations in the first equation that we derived. Okay, so what was the first equation? I'll rewrite that. The first equation that we derived was 1000 x1 equals wx2 plus wx3. This is the first equation that we have. So what I'm going to do is I'll take this x2 here. I'm going to substitute it here. I'm going to take x3 and I'm going to substitute it here. The equation that we'll end up with is it's going to be 1000 x1 equals w. Instead of x2 we will use x1 over 2 and instead of x3 we'll use twice x1 and add these fractions up on the right hand side. So we get 1000 x1 equals 5 times w x1 over 2. This is x1. x1 and x1 cancels. So we get 1000 equals 5 w over 2. If we solve this, we'll end up with w being equal to 400 newtons. And let's go back and see if that, yes, we have an option here, option B, and that's the correct one. Okay, so let's move on to this. So we have a sample and that sample has a decay rate of an emission rate of 128 counts per minute. That means in 1 minute it's going to emit 128 particles, radiation, or whatever we are counting here. All right, half-life is 4 days. That means it takes 4 days for the sample to degrade, to reduce by half of its amount. So how long will it take for the rate of emission to fall to 32 counts per minute? So initially we have 128 is the emission rate. If you wait for one half-life, that is, if you wait for 4 days, the count is going to be reduced by 1/2. So we'll have a count rate of 64. If you wait for another 4 days, the count is going to decrease by 1/2. So you'll have 32 counts. So if you look closely, you need to wait 4 days and another 4 days. So if you wait 8 days, the count goes from 128, count rate goes from 128 to 32. So we just need 8 days. And that's it. Alright, so we're done with this one as well. I hope you found this video helpful. Give it a thumbs up if you liked it. I'll see you in the next video with some more questions to do. Take care. Hope to see you soon. Bye bye.